Hey guys, welcome back to our segment routing series. In the last episode, we went ahead and brought up the segment routing in our topology. And later on, we went through the theoretical concept of segment routing traffic engineering. In this episode, we will go ahead and start configuring SRTE, or also known as segment routing traffic engineering. That means we will go ahead and start doing these traffic steering or traffic engineering using this segment routing. So in this episode, we will focus on how we go ahead and enable the SRTE within our topology. And we'll also go ahead and explore the example of an explicit policy that we had learned in the previous episodes. So for this demonstration, I'm using a slightly different topology. My other topology is not available at the moment, but it is pretty much the similar topology where we have the IGP working end-to-end, as well as I've already went ahead and configured pretty much all the nodes with the config that we need for our segment routing traffic engineering. Don't worry, I will go ahead and walk you through all the config that is needed on every single node. That way, when you are building up your lab, you know, okay, hey, what is the configuration that we need to do to enable the segment routing traffic engineering in our topology. So if you recall, in the previous episode, we had talked about that once we have the SR running, that means once we have the labels configured, we can see the labels end-to-end. Now, SRT is really all about the information that your IGP has learned. Now, we need to take that IGP learned information and we need to feed that information to our SRT database. That means to SRT, database. And using that SRT database, we can go ahead and start creating these policies. And that way we can go ahead and start engineering the traffic within our topology. So very first thing we need to go ahead and simply do, we need to work with our router ISIS. In this case, we are using ISIS. So let's go ahead and quickly jump onto the topology. So in this case, let's go ahead and take a look at the example, the config that we need to do on our PE router 1. So let me go ahead and log into the console of this router. Let's log in with the username, password. And now this is our PE1 router. And if I go ahead and make sure that I have an IGP reachability quickly. So let's go ahead and try to ping this PE3 router, which is in loopback IP address of 192.168.0.7, 192.168.0.7. And as you can see, this PE1 router is able to reach PE3 and it can pick any different path. That means we have an end-to-end reachability. And if you recall, if I do say show MPLS forwarding, we would get to see our different labels that we have configured to their loopback. That all we have done in our previous labs. So now we will go ahead and take that IGP learned information. Now we'll go ahead and start feeding that information to our SRT database primarily. And we'll go ahead and do that under our router ISIS in this case. So let me go ahead and show the config that I've already done to save some time. So I'm doing show running config router ISIS and we are on router PE1. Let me go ahead and scroll all the config and then we talk about. So now if you take a look at here, router ISIS 100. Now the important command, where the command which is doing the magic, is this particular command, which is distribute link state. So this is the command that takes up all the IGP learned information and it will go ahead and start feeding that information to our SRT database. That is the most important command that we would need just to turn on the feed the information from IGP to SRT. Distribute link state means, hey, take the link state information and start distributing that into your SRT database. That is the most important command that we would need. And I have configured the same command on all the routers in this single topology. So you would go under your router ISIS IGP in this case, and you would say distribute a link state. With that, I went ahead and configured a few more commands. We are logging any kind of changes. Now, another important thing that you see under address family IPv4 unicast, we had configured this in the previous episode, a metric wide. And now we had configured the segment routing MPLS SR prefer. Now here, I'm adding two more commands really. What these commands is, okay, hey, for the MPLS traffic engineering, I'm really telling you the levels that I'm working with my ISIS. In this case, my ISIS is operating in both level 1 as well as level 2. This command is pretty cool command and important command. What this command says, okay, hey, in the MPLS, in the traffic engineering world, you can identify this router using the router ID, which is from the loopback. That means whatever is the loopback ID, in this case, the loopback IP address of this router is 192.168.0.5. I want to pick this loopback IP address as the router ID when we are looking into the TE database, basically. So if I have to identify this PE1 in my traffic engineering database, I can do that with the help of the loopback 0, because we are using the loopback 0 as the router ID. These are the only commands. So if you see, the major command here is distribute link state. So this command will take the IGP learned information again, guys, and it will put into the SRT database, basically. And this we had done earlier in the previous episode under interface 0. We went ahead under address family and we had configured the prefix SID. So now in this case, the prefix SID for this router is 1. And if you just want to take a look at the config on PE3 quickly, let's go to log into PE3 and just do simply here show run router ISIS again. And you would see under router ISIS, I've also configured distribute link statement. And then again under address family IPv4, same level 1, level 2, we are using the router ID loopback. And the loopback 0, we have assigned a prefix SID of 3 in this case. So this particular routers, the label is 16,003. Now again, we can come back to our PE router 1. We can go ahead and simply do show MPLS forwarding, and we can go ahead and look up that, okay, the PE1 really sees our PE3 router, because for PE3 router, the label is 16,003, and that's what we just saw. On PE3, the label index is 3. So now we know we have an end-to-end reachability. We have the SR running. Now we have just simply turned on the distribute link statement. That means we are now feeding our IGP learned information to our SRT database. Now let's go ahead and create very first simple traffic engineering rule, or we'll go ahead and start to traffic engineer the rule with the help of an explicit path. And if you recall, when we are configuring any kind of a policy had 3 very important things. There is a head end, that means a device on which we want to configure the policy. Then we need a destination, which we call an endpoint. Okay, hey, this is the end destination we want to reach. And then we were assigning a color value that was a numerical value to identify that particular policy between those pair of devices. So let's go ahead, and in this case, we will go ahead and configure a policy on router PE1. And we'll say, okay, hey, you need to reach router PE3, and we'll go ahead and define a specific path that we want it to follow. And we can go ahead and do that. Before that, if you want to see, if I do show running config segment routing. So if you take a look at under segment routing, there are a few things are configured. Like the global block is configured. I don't have any policies as of right now. So now we'll go ahead and configure our very first policy. So let's go to our router PE1. We go under configuration mode, and here we say segment routing. And what are we working with in this time, guys? We are working with the traffic engineering. So that's why now we go in the traffic engineering sub configuration mode. So we'll go traffic engineering. And there are quite a few things that we can go ahead and configure here. So very first thing for a policy, if you recall in the previous episode, for a policy, we have one or more multiple candidate path. And each path can have a different preference primarily. So the very first thing that we need to configure is our path. And in this case, we are working with a static policy. So we'll go ahead and use an explicit path. That means we will go ahead and dictate the path that we want our policy to take. So the very first thing that we need to go ahead and create is our SID list, or our very first path. So we'll go ahead and use the command segment list. So with the segment list, we can go ahead and give it a name, or we can give a word identifying name for a segment list. Let's call this segment list as SID list 1. So what are we doing here? We are just creating a static policy or an explicit path here. The name for that very first segment list we are calling is the SID list 1. So in this SID list, if you take a look at what are the different options, there are a few things, but there is an important command that says index. So index, next entry index simply. So we'll just call it index, and let's give it an index of 10. If you press a question mark here with the index, there are 2 possible things that we can go ahead and specify. Either we can give an MPLS label, or we can go ahead and give an address. So let's go ahead and look at MPLS as to first to start off. It says MPLS configuration, and it says, okay, hey, label, MPLS label configuration. Tell me the label configuration that you want to use. So the label configurations are like this in this lab, guys. So this is your node 1, followed by your node 2. So this is 16,001, 16,002, 16,003. This is 16,004. While this guy is 16,011, 16,012, 16,013, and 16,014. So now let's say we are saying, okay, hey, from P1, we want the system to go to potentially, let's say, this particular node P1. So the P1 has a label of 16,011. Again, if you want to confirm really, let's go ahead and quickly log into this node. And if I go ahead and do show run rar ISIS, you would see under loopback 0, the prefix that we are using is 11. So we can say, hey, P1, I want you to take this particular path. So that means the very first hop that I want you to go to this P1 router. So the P1 router has a label of 16,011. So this is the very first entry. Sorry, I have to say label. And the very first entry is in this case is 16,011. Now, okay. Once you reach to P1, there are a couple paths that you can take. We can make it longer. From P1, we can send it to P4. From P1, we can send it to P2. Or from P1, we can send it back to P3. Whatever path that you want to decide for your policy, you can go ahead and do that. So let's say I'm saying, okay, hey, after going to P1, I want you to go to P2. So P2 has a label of 16,002. So in this case, we'll say, okay, hey, index number 20 will be an MPLS label of 16,002. Now, once you reach this router, from here, I want you to go to this P2. The P2 has a label of 16,012. So I would just simply say, okay, hey, index of 30, an MPLS label of 16,012, P2. Once you reach P2, from there I want you to go to the P3. So P3 has a label of 16,003. So we can say index 40 with an MPLS label of 16,003. And now that concludes our explicit path. So we have created one segment list. The name of the segment list is we called Sid list 1. In that Sid list, we are using MPLS labels, which are your SR labels or the global prefixes or your prefixes to traverse the path. So in this, we are saying, hey, P1, you go to the first label, which is 11. From 11, you go to 2, then you go to 12, and then from you go to the last node, which is 3. Let's go ahead and create one more segment list. So I'll say segment list, and I'm going to call it Sid list 2 in this case. And again, index 10. And again, if you recall, there were two potential options. We can either use an MPLS label, or we can go ahead and also specify the address for the next hop address. So let's go ahead and use the address. So from here, from P1, I'm saying, okay, hey, I don't care how do you go, but I want you to come directly to this node, So I can go ahead and say, pick this particular next hop. So the next hop in this case is, let's say we want to use this one, 190, or maybe let's pick the other path. 192.168.0.3. So let's say 192.168.0.3. I think, yeah, I forgot to write the IPv4 because this is an IXR platform. So we'll have to say IPv4. Now, once you are using this, let's say from there, I want you to come down to this particular node, or maybe let's take it to 0.4. We'll just continue that path. 0.4, and that would be our index number 20 in this case. And last but not the least, go to 7. That will be our index number 30 from there. And at this stage, what we have just done, we just simply went ahead and configured two SID lists. So these SID lists will serve as the path under our candidate paths. Okay. Now the SID list is configured. Now let's just simply do a commit here. I want to save my changes, and if I do a show run on the segment routing, now we would see these two SID lists being seen under segment routing traffic engineering. The very first segment list that we created is SID list 1, where we are using the MPLS label to traverse the path in the topology. we created second SID list where we are using the IPv4 addresses to traverse the path inside our topology. That's what we had seen, that with the explicit, we can go ahead and either use MPLS labels or we can go ahead and use the IPv4 addresses. Okay. Now the IPv4 addresses, we can either use a prefix SID or as well as we can use the adjacency SID IP address also. And we could have done the same thing with the MPLS labels. Now if you see, we are all using the node IDs or the prefix SID. You have the option to use the adjacency SIDs also if that's what you wanted. Okay. Now once these paths are created, now time to create a policy. So let's go ahead and create a policy. So the policy starts with the keyword policy followed by a name. Let's call it our policy 1. So now when you are inside a policy, the policy had a few things. If you recall, an head end, in this case P1 serves as your head end. We need a color and then we need an endpoint, which is your destination. So let's say we want to reach P3. So now we'll go ahead and say color. So if you clearly say specify color for a policy, so let's say color question mark, and if it says okay, hey, color will be a numerical value, so let's call it, let's say color number 20. After color it says okay, hey, tell me the endpoint, what is your policy endpoint. So we'll go ahead and say endpoint here, and in the case of endpoint it's an IPv4 address. So let's go ahead and take a look at the IPv4 address that we want to reach. So the IPv4 address is the loopback IP address of your PE3, which is 192.168.0.7. So I'll go ahead and say the same thing, 168.0.7. So this is our endpoint. There are no further options, so let's go ahead and simply press and enter. So what we just did, we created a policy PO1. In that policy, we have just specified a color as well as an endpoint. So now a policy needs what? A path to reach from this head end to this tail end or this endpoint. So we need path, which are called as your candidate paths. Paths, that means we can have more than one path a given time within a policy, and each path will have its own preference. Higher the preference, better the path basically. So let's go ahead and do that. Now we are still within our policy. Now in the policy we'll go ahead and say, hey, the candidate paths. So if you look at, there are different options within the candidate paths. The very first thing it says, okay, hey, tell me the preference for this path. So let's go ahead and say a preference. And I'm giving this is again a number if you just want to take a look at. So I'm saying a preference of 300. So within a preference, there are a few things that you can go ahead and configure. And one of the things that you see here, it says explicit, which says a pre-configured path. So we have already configured path, the SID list 1 and SID list 2. So that's what we are going to use. We'll say here explicit. With the explicit, it says, okay, hey, tell me the segment list that you plan to use. Segment list. Now with the segment list, we have two options, SID list 1 and SID list 2. So let's go ahead and say, hey, I want to use SID list number 2 in this case. So we just configured a preference of 300, and under that preference, we gave our path. The path name is SID list 2. Now let's just come out and we'll go ahead and configure another preference. So we are still under preference. Let's come out one more level. So we'll say preference of 500, and for this preference we are again using an explicit path with the segment list. In this case, let's say use the segment list number 1. So now if this stage, if I go ahead and simply commit my changes, and let's go ahead and do a show run again on segment routing. Now if you take a look at here, what we just configured, we had configured these two segment lists, which are your explicit path, segment list SID list 1 and SID list 2. Then we went ahead and configured a policy by name PO1. We configured a color and we gave an endpoint destination. Then we configured candidate paths, multiple path for this our policy. So we are saying for preference 300, I'm using SID list 2. That means, hey, for preference 300, use this particular SID list where we are using IPv4 addresses. For preference 500, I want you to use the MPLS label, which is our SID list 1. And if you recall, higher the preference, better the path primarily. So what we just done here, we can also we could have also assigned a weight to these particular policy also. So that means instead of giving a preference within the same preference, we can give a two policy, but with the different weights if we really wanted to do that. So now once the policy is configured, now let's go ahead and take a look at on the head end what happened to this policy. So I'm going to come out here. Now we go ahead and simply say, hey, show segment routing, traffic engineering, and we want to take a look at the policy. So in this case, there is only one policy. So let's go ahead and simply press enter here. Let's just look at the whole output, and then we're going to go ahead and scroll these things further up. So if you see in this policy, it says, okay, here the policy color is 20 and the endpoint IP address is this particular. If you see, this name was automatically derived here. This is auto-generated name. So this name kind of uses your color value as well as your endpoint in this case. That's how you see the endpoint is 20 and the color is 20, and this is your endpoint 0.7. The next line really indicates, okay, the policy is admin up as well, it's operationally up. That means the path that we have configured, those are valid path, and the policy is able to consume those path and it is able to reach the endpoint, and that is why the operational state of this policy is really up. So in that, there are these candidate paths. It says, okay, here right now it is using a preference of 500 and it's a configured path which is active right now. If you recall, candidate path, which is SID list 1, is a valid because it is with the higher preference. The higher preference in this case is the 500, and that is why we see this path as being kind of active. And that's what you can see here under explicit. It says, okay, hey, it is using an explicit list and the name of that list is 1 and it is a valid list simply. Okay. Now within that list, if you take a look at, this is the name of the policy, and if you look at this binding SID, right now we are saying the binding SID value is dynamic. That means we did not configure any binding SID for this policy. We are asking system to go ahead and generate the binding SID for this one, and this is the symbolic name for this policy, and we'll go ahead and discuss this a little in later detail. But now if you take a look here, it says, okay, hey, the weight of this policy is 1, and by default the static policy uses a metric type of TE, which is your traffic engineering. And in this policy it says, okay, hey, this was the first prefix that we configured. That's why you say it's a prefix SID, and it was able to find out, and you can see for this prefix SID what is the loopback IP that was associated, and it shows, okay, hey, these are the different hops that it needs to go ahead and cross over here. Okay, so that's what we can go ahead and see. Now in here we do see a preference 300 right now. The requested for that one is also dynamic, but if you take a look at here, what it says, it is invalid. At a given point of time, there can be only one policy or one path which will be active. That's why the second path just simply says invalid over here. Okay. Now if you take a look at it here, it was saying, okay, hey, the binding SID is dynamic, and if you take a look at, okay, the binding SID that was generated for this is 24,005. This is a dynamic value because you can remember, because this label is really like 24,000, and if you recall, those labels are really your dynamic labels here. Okay, and that's how we can go ahead and see some of these information. And this is what the output that we are looking. This is your SRT database, and it clearly over says, okay, here SRT policy database. So the command is fetching all that information from SRT DB, and this SRTV is getting some of this information from your IGP. Okay, so now if you take a look at the binding SID that was being assigned or created for this is 24,005. So now we can take a look at this binding SID on our forwarding table on our head end. So what we can say, hey, show MPLS forwarding, and we want to take a look at the label, and the label is 24,005, and show me the detail for this particular label. So what the system says here right now, okay, hey, the binding SID that was programmed, now this binding SID, it becomes as a local label. Okay, and this local label really points to the outgoing interface, and in this case the outgoing interface becomes that SR policy that was just generated, and that's why you can see your policy name here over here, where it is using that color 20 and some of the other pretty much other things. Now if you take a look at here the label, so what it says, okay, hey, it's an unlabeled and implicit null. So this unlabeled doesn't mean anything basically, as the forwarding decision is given to this particular policy in this case, okay, which happens to be the outgoing interface. So this SRT policy will impose additional label as needed. Okay, so that's the thing you are looking at over here. For this thing, these are again, path and what is the interface being seen and some of the other things. We can also go ahead and look up the same policy into the forwarding table also. So for that, we can just say show segment routing, traffic engineering, forwarding policy, and we can say give me the detail for this particular policy. Okay. And now if you scroll this further down, what it says, okay, hey, for the color 20, this is the endpoint, and it shows that is the binding SID that is being used. And if you take a look at it, when anybody is trying to send anything to this binding SID, it will use this as outgoing interface. And that's what you see when somebody will use this policy. These are the labels that are labels will be imposed. So the labels are 16,002, 16,012, and 16,003. And if you recall, these labels are the one that we had configured manually within our policy. And this shows, okay, hey, the path this is going to take. So it says it is going to use the gig 0000. And again, these are the labels that are being imposed when something needs to go to the other side. We can also take a look at this in a different way. We can say show Ceph for the 192.168.0.7/32. So what the system says, okay, hey, if you need to reach this particular endpoint, the labels that are going to be imposed again, 16,003 in this particular case. And that's kind of the example how you can go ahead and start traffic engineering your routes with the help of this SRT. So we just saw an example of the SRT using explicit path, where we went ahead and configured multiple candidate paths. So let me go ahead and quickly do a show run segment routing traffic engineering. So we configured multiple SID lists based on any of these labels as well as the IP addresses, and then we are consuming them within our policy. And you can see the policy is getting programmed in the forwarding table. So if we'll have any interesting traffic, we can go ahead and use that. You can also go ahead and configure like static routes specifically towards this SR policy if you need to do that. And that way you are making sure your traffic is always steered using that TE tunnel to your destination. So that will be all for this particular episode, guys. In the next episode, we will go ahead and learn how to create these policies, but we will go ahead and explore the dynamic aspect of the SRT. So I'll see you guys in the next episode. Thank you.